Welcome to the third video on AWS Solution Architect Certification sample practice questions. In this video, we're going to focus on Compute ALB API Gateway. Okay, let's look at the first question. So you have an automobile company that recently chose AWS as its cloud platform and is looking to migrate its data analytics application to AWS. The cloud architect is planning to use EC2 as a compute service. As the application can tolerate interruptions, it is looking to use spot fleets. While defining the spot fleet allocation strategy, it wants to minimize the interruptions, even if it means paying slightly higher cost for spot instances. So you have an analytics application which can tolerate interruptions, and it wants to use spot fleets to reduce cost. But what is critical here is that it wants to minimize the interruption while using the spot fleets, even if it has to pay slightly higher cost for spot instances. So let's take a look at the solution. Use capacity optimized strategy. It automatically launches spot instances into the most available pools by looking at the real-time capacity data and predicting which are the most available. By offering the possibility of the fewer interruptions, the capacity optimized strategy can lower the overall cost of the workload. So when you are using spot fleets, you have different strategies available. One of them is capacity optimized. So what capacity optimized strategy does is it looks at which kind of instances and availability zones have the most available pools, because if there is a larger pool, that means there is very less possibility of a workload being, or EC2 instance, spot instance being terminated, compared to the lowest price allocation strategy. In the lowest price allocation strategy, what happens is you get the EC2 instances with the lowest price, and if they have a lower pool available in that availability zone, it will interrupt. So if you want the lowest cost, then you look at the lowest price allocation strategy. If you want to minimize interruption at the same time pay slightly higher cost than the lowest price allocation strategy, you use capacity optimized. So this looks pretty much the correct answer to me, but let's look at the other options. So the second one is use the lowest price allocation strategy. It deploys the cheapest number of instances, types, and availability zones based on the current spot price across the number of spot pools available. So this does not guarantee minimize interruption, but it guarantees the lowest cost. Okay. Now, capacity optimized strategy automatically launches spot instances into the most available pools by looking at the real-time capacity and predicting which are the cheapest. By offering the possibility of the cheapest instances, the capacity optimized can lower the overall cost of your work. Okay, so this is not the correct one, because you can see it is talking about real-time capacity data and predicting which is the cheapest, but it's not looking at the cheapest. It's looking at the one which is most available, right? And then let's look at the last one. The lowest price allocation strategy automatically deploys the cheapest combination of instances, types, and availabilities with the least interruption based on the spot price across the number of spot pools that are specified. Again, this is not the correct one. So let's take a quick look at where this is defined by AWS in the documentation. So you can see here. So here we go to spot fleets. Okay, so here it defines what a spot fleet is. It's basically a set of spot instances and optional on-demand instances that can be launched based on the criteria that you specify. So you have various strategies here. So I go for the allocation strategy. The allocation strategy for spot instances determines how it will be fulfilled. So it can be capacity optimized, where it looks at what are the maximum number of instances available that when you launch are going to minimize the interruptions, but still give you the benefit of using the spot fleet. Then you also have the option of configure the spot fleet for cost optimization. So this gives you the lowest cost, but there is also possibility of a higher interruption. Okay, so the correct answer for this one is the first one. Okay, now let's look at the next question. So this should be a pretty straightforward one. Startup has launched a new cutting-edge fitness equipment to help reduce waste. It is looking for to develop a web application based on microservice architecture and no SQL database. Application needs to be highly available, scalable, and serverless as much as possible. Which of the following AWS services would be a good fit? Okay, now let's take a look at the options. The key requirements that we have is it should be highly available, scalable, and serverless as much as possible, and it should also use a NoSQL database. So let's look at the first one. So you have the use ELB, use containers Fargate. Okay, so this is serverless, and then you have launch type as Fargate as launch type, and RDS Aurora. So RDS Aurora is a SQL database, and what is it asking? It's asking for a managed NoSQL database. So this option doesn't seem to be the correct one. Let's look at the second one. So use a combination of API gateway. Yeah, microservices API gateway makes sense. ECS containers and with launch type as Fargate. Again, Fargate is serverless. So this makes sense. And the third one, RDS Aurora. Again, so it's a SQL database. It's looking at NoSQL. So this is not a correct one. Now let's look at the third one. So you have the use ELB. You have the ECS containers with EC2 launch type. Okay. And the third one is you have the DynamoDB. Okay, so this fits the bill. So it's no SQL database. ELB is fine, but here you can see EC2 launch type in the containers. It is not serverless. Again, so this is not the right fit. Then you have the last combination. So you use combination of API gateway, you use ECS containers, Fargate as launch type, and DynamoDB. So it meets all the three requirements. So you have the NoSQL database, you have the serverless ECS container, and then you have the API gateway. So this is a typical combination of most microservice based application: an API gateway, either ECS containers, maybe Fargate, or even Lambda function. And then on the database side, if you need NoSQL, then use DynamoDB. Otherwise, you use RDS, either RDS Aurora or RDS MySQL, etc. Okay. So now let's go on to the next question. Yeah, this is the right one. Okay, now let's take a look at this one. A pharmaceutical company wants to share their research findings for cancer treatment with specific partners as a SaaS service who can access their application on the AWS VPC. The company's partner have their VPC on the AWS as well, but with an overlapping CIDR blocks. What is the recommended way to share the data with partners with overlapping CIDR blocks? The data should be privately, and public interest should be avoided due to confidential nature of the data. So what are our key requirements for this question? So first, it should be both the partner and the pharmaceutical company are on AWS. So they want to expose their data as a SaaS service. So that's the first one. Second, they have overlapping CIDR blocks. And the third one is they want it to be shared privately and not on the public internet. Okay, so these are the three key requirements. Now let's look at what are the options we have. So enabling VPC peering, then use the longest prefix match algorithm to overcome the challenge of overlapping CIDR blocks. Okay, now if you have enabled VPC peering, you have overlapping CIDR blocks, that's not really a recommended way. Yeah, so this probably is not the right solution. Now let's look at the second one. Use a transit gateway attachment in each of the partner VPC and connect them to the VPC of the other pharmaceutical company to route the traffic privately. So transit gateway would usually connect multiple VPCs of an organization. And in this case, if you have overlapping CIDR block and you want to expose the data as a SaaS service, this is typically not a recommended solution by AWS. So we'll leave that out. Okay, now create a web application and limit the access to specific CIDR blocks from the partner companies. So you create a web application and limit the access to specific CIDR blocks, but your CIDR blocks are already overlapping, so it might not be a great fit. Now let's look at what's the fourth one. So you create VPC endpoints in the partner consumer VPC and then allow traffic to be routed using AWS private link to producer VPC, which is the pharmaceutical company VPC, and which is exposing their data as a SaaS service using NLB endpoint service and partner application. So this is the recommended method when we want to expose an application as a SaaS service privately being consumed by your partner. So let's take a quick look at the diagram. So this is the AWS white paper which describes this scenario. So privately connectivity to cloud-based SaaS service. So here you have the consumer VPC, and then on the right you have the service provider VPC or SaaS provider VPC, which is offering its service as a SaaS. So in the consumer VPC, what you do is you can see here, it has created the different Elastic Network interfaces. So you create an interface endpoint, and then you use the AWS private link to transfer the data securely and privately, which goes to the network load balancer, which you have on the service provider VPC. And here you create the endpoint service. So this is a typical way in which you can expose data as a SaaS service to your partners. Okay, so the final answer to this one is the one which we just discussed, the fourth one. Okay. Now let's take a look at the next question. A global retailer has adopted hybrid cloud architecture. It needs to route some API requests from on-premise application to microservice-based application hosted on ECS frontend with ALB in AWS. It is looking to route traffic to ALB from on-premise, and for that purpose, it needs to whitelist ALB's IPs. However, when the load to ALB increases, the underlying IPs of the ALB change, and thus the requests fail as the new IPs are not whitelisted in the organization firewall. What is a good solution to mitigate this challenge? So this is a common challenge sometimes in some of the enterprises where you are trying to route the traffic from on-prem to an ALB with the application having microservices having the microservices architecture. So now let's look at the options that you have, and it needs to whitelist the target IPs in its on-premise data center firewalls, but the IPs of the ALB keep changing. So how do you mitigate this challenge? So you can use an AWS VPN and transit gateway to route traffic from on-premise AWS, which will eliminate the need to whitelist the IP address in the organization firewall, as the data will be transferred through the dedicated network. Yeah, that's correct. You can either use AWS VPN and transit gateway, which would establish the connectivity between your on-premise data center and AWS VPC, but this does not mitigate the challenge of whitelisting the IPs to which that on-premise traffic needs to be routed. So this doesn't seem to be the right answer. Use NLB, use a network load balancer, route traffic from on-premise to NLB, and whitelist the two fixed IPs. Yes, that's correct. We'll need to use the NLB because NLB provides you with two static IPs in two availability zones in your VPC, and you can route traffic to them, but then it doesn't highlight how that traffic is going to be routed from NLB to ALB. So this is an incomplete answer, though partially correct, but an incomplete answer. Use direct connect and transit gateway to route the traffic from on-premise to AWS, which will eliminate the need to whitelist IPs and transfer, which is transferred through a dedicated network. Yeah, it seems very similar to the first one. Again, it doesn't solve our problem. You will need a direct connect or an direct connect and transit gateway to establish connectivity between your on-premise data center and connecting various VPCs through the transit gateway, but it doesn't solve our challenge of pushing the data to fixed IPs. So what's the final option? Use an NLB. Okay, NLB will provide us two fixed IPs to which we can route the traffic. Route traffic from on-premise NLB and whitelist the two fixed IPs. Okay, from NLB route the traffic to ALB and update the IP of ALB in NLB using the AWS Lambda function. The AWS Lambda function will keep everything in sync by watching the ALB IP address change and update the NLB target group. So what would happen is you will have two fixed IPs from the network load balancer. You will route all the traffic to those two fixed IPs. Then what will happen is that traffic from the NLB will be routed to ALB, and Lambda function would monitor the IP address of the application load balancer. When they change, it will update the target group in the network load balancer. Let me just show you a quick diagram on this. So you can see in this white paper, in this blog, AWS blog, they have described. So you will have the client side firewall whitelist IP address of these two IPs of the network load balancer. This traffic will be routed to this network load balancer, which will then route the traffic to the application load balancer. And previously what we had to do was, and this is implemented if these were implemented, these solutions were implemented before 2021 in most organizations who are trying to build this kind of architecture, where you will have the Lambda function looking at the IP, watching the IP of the application load balancer once they change, update in the S3 bucket, and then update, store in the S3 bucket those new IPs, and then update the target group for network load balancer. But of late, you can see on September 27, 2020, we launched an application load target type for network load balancer. So previously, you could not directly have application load balancer as a target group. So you would have to use the fixed, you would have to use the static IPs as the target groups, then which would route to ALB. But now, having these Lambda function to update the IPs of the network load of the application load balancer in the network load balancer is not required, and you can directly have the application load balancer as target group of network load balancer. But the solution pretty much remains the same, where you whitelist the IPs in your on-premise firewall, which direct traffic to network load balancer, which goes to the application load balancer. Okay, so that's pretty much the answer for this one. That's pretty much from this session. Thank you very much.